Hi, myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. The topic is left recursion and how to eliminate left recursion. A grammar is left recursive grammar when rules of the grammar will be in the form A derives A alpha or beta. A derives A alpha or beta. Here, left hand side of the arrow is A. Left hand side of the arrow is A, that is a single non-terminal. A is a single non-terminal, and right hand side RHS. The first symbol of RHS is also a non-terminal, that is same as LHS symbol. If the first symbol of RHS is same as LHS symbol, the rule will be recursive rule. If any grammar containing the rules will be in the form A derives A alpha or beta, we can say that the grammar is left recursive grammar. So, the above grammar in this example, the above grammar is left recursive because left of production is occurring at a first position on the right of the production. Left of a production occurring at the first position on the RHS. This is left of a production occurring at a first position on the RHS. We can say that the grammar is left recursive. So, top-down parsers cannot handle left recursive parsers. We need to eliminate left recursion. We can eliminate left recursion by rewriting these rules. A derives A alpha or beta can be rewritten as A derives beta A dash derives alpha A dash or epsilon. These two rules are replaced by these three rules. See this once again. A derives beta A dash, this is beta rule. A derives beta A dash is a new non-terminal we have introduced. A derives beta A dash derives alpha A dash or epsilon. This is the rule we have to follow to eliminate left recursion. See this, A derives A alpha or beta is replaced by A derives beta A dash derives alpha A dash or epsilon. See this. Removal of left recursion causes right recursion. See this, if you repeatedly apply A derives A alpha, A derives A alpha, A derives A alpha and so on, it will enter into a loop, that is left recursion. If you remove left recursion, we can get right recursion. A derives beta A dash derives alpha A dash derives alpha A dash and so on. A dash derives epsilon. So, removal of left recursion causes right recursion. Right recursion can be handled by the top-down parsers. Next, left recursion. Left recursion general rule. The general rule will be in the form A derives A alpha 1 or A alpha 2 or A alpha 3 and so on, A alpha m or beta 1 or beta 2 and so on, beta n. This is a left recursive grammar because left hand side of the arrow is same as first symbol of the RHS. First symbol of the RHS. Beta 1, beta 2 and so on, beta n are the beta rules. We can replace these rules by A derives beta 1 A dash, beta 2 A dash, beta 3 A dash and so on, beta n A dash. What is A dash? A dash derives alpha 1 A dash, alpha 2 A dash and so on, alpha m A dash, finally epsilon. Like that we can replace left recursion by using these rules. Let us consider this example. E derives E plus T or T. T derives T star F or F. F derives parenthesized G or ID. If you take this first rule, E derives E plus T or T. This rule will be in the form A derives A alpha or beta, because see, compare this rule with this rule. Here E is same as A, so that A is equals to E, alpha is plus T, beta is t. So that we can replace this rule by eliminating left recursion. A derives beta a dash derives alpha a dash or epsilon. Like that, E derives beta means t, beta means t, beta a dash, E derives t E dash. What is E dash? E dash derives alpha a dash. What is alpha? Alpha is plus t, alpha a dash. A dash means E dash plus t E dash or epsilon. So, this rule is replaced by these rules. E derives t E dash, E dash derives plus t E dash or epsilon. Then take this rule. T derives t star f or f. It is also same as A derives A alpha or beta. The rules will be replaced by eliminating left recursion. A derives beta a dash derives alpha a dash or epsilon. A derives beta a dash derives alpha a dash or epsilon. Here A is equals to t, alpha is equals to star f, beta is equals to f. We can rewrite these rules by eliminating left recursion. A derives beta a dash, beta means f, t derives f t dash derives alpha means star f t dash or epsilon. See this rule is replaced by these two rules. T derives t star f or f is replaced by t derives f t star derives star f t dash or epsilon. Last rule, f derives parenthesized e or id. This rule is not in the form of E derives A, alpha or beta, because LHS, first symbol of RHS, both are different. So that this rule will be written as it is. Like that, we can eliminate left recursion. Another example for elimination of left recursion is, consider the following grammar and eliminate left recursion. S derives parenthesized L or A, L derives L comma S or S. See, S derives parenthesized L or A is not in the form A derives A alpha or beta, because this symbol and the first symbol of RHS are different. So that we will keep this rule as it is in the after elimination of left recursion grammar. Then consider this rule. L derives L comma S or S. Yes, this rule is in the form A derives A alpha or beta. After elimination of left recursion, the rules will be A derives beta A dash derives alpha A dash or epsilon. So that here A is same as L, alpha is comma S, comma is a terminal here, beta is S. Then we can rewrite this rule after eliminating left recursion. L derives beta A dash, A derives beta A dash. So that L derives beta A dash. What is beta? S. L derives S L dash. What is L dash? L dash derives A dash derives alpha A dash. What is alpha? Comma A. Comma is also you have to write comma S. A dash derives alpha A dash. So that L dash derives comma S, L dash or epsilon. See this. This rule will be replaced by these two rules. Like that, we can eliminate left recursion. Thank you.